For this task, I set myself the goal of creating a hands-on mathematics teaching prop for Year 3 and Year 4 students. It can also be used for other years, but this is my focus. I wanted to design a resource that would improve student engagement and support multiplication, division, addition, and subtraction in a more interactive way. During mathematics lessons, students can sometimes become disengaged when learning only through worksheets or written tasks. So I wanted to create something physical that students could manipulate themselves while solving equations. The final product I created was a rotating mathematics prop made from coloured cardboard discs attached to a skewer. 4 of the discs displayed numbers. We've got this one, this one, this one, and this one. And one disc displayed equal symbols, one disc displayed the mathematical equations, plus, minus, divide, and multiplication. Students can rotate the discs to generate different equations involving all of the 4 equations. We've got multiplication, division, addition, and subtraction. It can be used independently or within small groups during maths activities. So we can make it rotate to, say, for example, 8 minus 1, 8 minus 1 equals, we'll have 0, 7. Throughout this task, I followed the creating designed solutions process involving investigating and defining, generating and designing, producing, and then evaluating. One of the first process strategies I employed was sketching the initial ideas. I created several rough design sketches to explore possible structures, different disk arrangements, different base designs. This helped me visualize how the prop would function before beginning my construction. Another important strategy I employed was testing prototype designs. Before finalizing the prop, I explored different ways of positioning the discs and different ways to support the structure. This stage helped me identify potential problems early in the process. For example, one of my early designs positioned the discs too closely together, whereas I've opted out for slightly further apart. Although the design looked a bit more compact, it did prevent them from rotating smoothly. As you can see here, they rotate quite well. As a result, I modified the spacing between the discs to improve movement and functionality. Increasing this space allowed the disc to move freely, and it just made the equations easier to read. This demonstrated how important testing and refinement were within the design process. I also refined the base size throughout construction. My original base was quite narrow and it wasn't very stable, which caused the prop to move around during the use of it. To solve this issue, I increased the size of the cardboard base and adjusted the side supports. This improved the balance and overall structural stability of the product. As you can see here, the base is quite a bit wider than the discs, offers a bit more stability while still being stable. Selecting stronger materials was another important process strategy. Initially, I considered using thinner cardboard because it was easier to cut. However, I realized the thinner cardboard did not provide enough structural support for the rotating discs and the wooden skewer. I eventually selected a thicker cardboard, which you can see it's quite thick everywhere. It improved the durability and structural integrity of the prop. Just for repeated use, it was really good. Problem solving during construction became a major part of the project. One of the biggest problems I encountered was improving the structural integrity, specifically of the side supports. The original supports bent slightly under the pressure of the skewer and the rotating discs. To solve this issue, I reinforced the supports with this thicker cardboard. It just improved the strength of the whole structure. As you can see, they don't bend in, they stay nice and straight. Another important strategy I used was evaluating what was not working throughout the process. Rather than continuing with ineffective design choices, I tested the prop and reflected on what needed improvement. This allowed me to identify issues involving movement, balance, durability, before actually completing the product. Making these improvements after testing was essential to achieve a functional final design. Each modification improved the practicality and the usability of the prop, for example, increasing the space between the discs, and also increasing the size of the base, improved balance, and just overall usability, made it more user-friendly for students, which has been really fantastic because I was able to use this in class, which is why it's a bit bent. I need to replace the skewer. Planning materials and tools before construction was also an important part of the process. Before beginning construction, I identified the materials and equipment required: cardboard, coloured paper, skewer, ruler, scissors, different marker, masking tape. Planning all these materials beforehand helped the construction process run more smoothly and reduced interruptions within the process of construction. Also, managing the safety during construction was another important consideration. I maintained a clear workspace throughout the whole task. This reduced hazards and improved my organisation. I also used scissors carefully during the construction, ensuring that there was supervision when I used the scissors and the stapler. Safety became an important reminder that practical classroom activities require clear expectations and clear management to be effective. Overall, the task helped me better understand the importance of planning, testing, evaluating, and refining ideas during the technologies process. It reinforced how valuable hands-on learning can be for student engagement, and demonstrated how design solutions often improve through trial and error, a bit of reflection and modification. Overall, this experience has influenced how I would approach technologies learning in the classroom, because I now better understand the importance of allowing students time to experiment, solve problems, and refine their ideas through this design process. So yeah.